Students, in today's session, we shall discuss about strong field ligands and weak field ligands in coordination compounds. So it is a very important or excellent trick to find strong field ligand and weak field ligand. So if you know the sudden coordination compound containing strong field ligand or weak field ligand, then you can solve any kind of coordination complex compounds regarding geometry or hybridization, inner orbital complex or outer orbital complex, high spin or low spin complex, and paramagnetic or diamagnetic nature. So these you can solve if you know strong field, which is strong field ligand and which is weak field ligand. Because in the presence of strong field ligand, electrons will be paired, and in the presence of weak field ligand, electrons will not be getting paired. In such case, hybridization will be varied. Then geometry will be same. No, okay, does not matter. But paramagnetic, diamagnetic nature will be varied, and inner orbital, outer orbital, high spin, low spin complex. So these will be varying depending upon the nature of the ligand. So this is a very important concept that each and everyone should know. So let's find out. So here weak field ligands. Ligands in which donor atoms are halogens, oxygen or sulfur. So then they are weak field ligands. So ligands, whatever it may be, if it contains halogen as a donor atom, oxygen as a donor atom, sulfur as a donor atom, so then we can consider such ligands are weak field ligands. Some examples I can give you here. Examples: all halogens like fluorine, fluoride ion, chloride, bromide, iodide. So these are all weak field ligands. So along with these ligands, OH minus. So here oxygen is a donor atom. Donor means the atom which is donating a pair of electrons to the metal atom is called a donor atom. If oxygen, so in this one, oxygen is a donor atom, so it is a weak field ligand. You have to keep in mind how to find. Then OH minus, then SCN, thiocyanate ion. So it is a ambidentate or bidentate ligand. So in this one, sulfur is a donor atom. So it is a weak field ligand, SCN minus. Or SNC, isothiocyanate, also we can find SCN or SNC. Then C2O4 2 minus. So actual structure will be COO minus, COO minus. So here these are donor atoms. So these will be donated electron pairs to the metal atom. So here in such case, oxygens are donor atoms. So these are all weak field ligands only. Understand? Next, let us move to strong field ligands. Strong field ligands. So strong field ligands. What are the strong field ligands actually? So ligands in which carbon, nitrogen, phosphorus, these are donor atoms. Such ligands are weak field ligands. Okay, ligands in which carbon, nitrogen, phosphorus, these are donor atoms. Then we can consider those ligands as strong field ligands. So some of the examples are Cn minus. So in this case, carbon is a donor atom. Then Nc minus, because it is ambidentate ligand. So in such case, nitrogen and carbon both are the donor atoms. Ambidentate ligand. Cn minus is ambidentate ligand. So here in if carbon is a donor atom and if nitrogen is a donor atom, so in both the cases it is a strong field ligand, Cn minus cyano. Then carbonyl CO. In such case, carbon is a donor atom. Then NH3. NH3 here, nitrogen is a donor atom. It has a lone pair. So it can donate electrons to the metal atom. So it is a strong field ligand. Then ethylene diamine. CH2, NH2, then CH2, NH2. So here nitrogen containing lone pair. So these will be donated to metal atom. So here in such case it is a strong field ligand. Then dimethyl glyoxamate, COO minus, then CH2 and NH2. In this case, nitrogen will be donated to electron to metal atom. Okay, dimethyl glyoxamate. Then ethylene diamine tetra acetate. So ethylene diamine tetra acetate. In such case, oxygens are donating ethylene diamine tetra acetate. Then triphenyl phosphine. So phosphorus can donate electron pair, and trimethyl phosphine. In such case, phosphorus donate electron pair to the metal atom. So these are all considered as a strong field ligands, because in these cases, carbon, nitrogen, phosphorus are the donor atoms, and in case of weak field ligands, oxygen, halogens, and sulfur are the donor atoms. So that trick you have to keep in mind. Okay, so this is a very excellent and important trick for the coordination compounds for find out strong field ligands and weak field ligands. Thank you. If you like this video, give a thumbs up for the video and subscribe to my channel for more chemistry related concepts. Thank you for watching.